Let's do an example. So a soccer ball is kicked off the ground at a height of 0 meters. It reaches a maximum height of 10 meters after 3 seconds and hits the ground at 6 seconds. Determine an equation for height as a function of time and its domain and range. So the first thing I always like to do with a question like this is start off with a diagram. And let's label what the x-axis and the y-axis would be. So we're determining an equation for height as a function of time. So we know that height is the dependent variable and time is the independent variable, or the x-axis. So the ball starts at 0 seconds at a height of 0 meters, and then it's kicked. It reaches a maximum height of 10 meters at 3 seconds. And then I'm just going to extend this graph here. And then it hits the ground at 6 seconds. So this point here represents the vertex of this parabola, and it's 3 and 10. Now, to make an equation for this graph, there are many ways you can do it. You can use the factored form of a parabola because you have the intercepts. You can also use the vertex form, which is what we're going to do in this video. And if you remember, the vertex form of a parabola is x minus h squared plus k, where the h and the k represent the coordinates of the vertex. So this form is the same as this form, where the 3 and the 10 represent the vertex of our parabola in this example. Now, you may have to go back and review your grade 10 notes on how to deal with the vertex form of a parabola and how to find the equation. More specifically, we have to solve for this a value. And if you remember, the way that we solve for this a value is we have to pick a coordinate on the parabola other than the vertex, and then a would be the only variable remaining, and then we isolate for it. So picking coordinates, we could use this origin coordinate, which is 0, 0. We can also use this t-intercept of 6 and 0 because that's when the ball hits the ground. So either or, I say we use the origin as it's probably going to be easier to work with. So plugging in 0 for h and 0 for t, we now have to solve for a. So this would be 0 minus 3 squared is 9, so we'd have 9a plus 10 is equal to 0. Bringing the 10 over, that becomes a negative 10, and then dividing both sides by 9, so we have a is equal to negative 10 over 9. So with that a value, our final equation ends up being h is equal to negative 10 over 9 t minus 3 squared plus 10. So we answered the first part of our question. And now we have to find the domain and range for this scenario. Now, if we were given just this equation without this scenario and we were asked to find the domain and range, then it would be a little bit more simple because we know that this is a parabola that opens down with a vertex at 3 and 10. And we know that for a parabola, the independent variable could take any value, so the domain would be t can be anything. Remember, t is the independent variable in this case. And then the range would be all y values that are less than the vertex of 10. So the h value can take anything, however h has to be less than or equal to 10. However, since there is a scenario attached to this function, we're not just dealing with the abstract case. We have to be a little bit more restrictive with the domain and range because time can't be negative and height can't be negative either. So this here would not be good enough, this domain and range that we put for this abstract parabola. So what would the domain and range be for our specific scenario? So figuring out the domain and what values the time can take, notice how the time can only be between 0 and 6 seconds. Because before 0 seconds, you would have a negative height and a negative time, which doesn't make sense. And after 6 seconds, you would have a negative height, which also doesn't make sense. So the t value can be anything, however, it has to be between 0 and 6 seconds in this scenario. Now, what about the range? What values can the dependent variable of height take? Well, it reaches a maximum height of 10 meters, so it can't be anything above that. And height can't be negative, so the minimum height value is 0, and that's when it's on the ground initially and when it hits the ground at 6 seconds. So the height can be any value as long as it's between 0 and 10 meters. So that's it. Those are our domain and ranges for this scenario. And notice how they're a little bit more restrictive than the abstract domain and ranges for this parabola if there was no scenario attached to it. So just remember that whenever they're asking you for the domain and range of a specific real-world scenario, you have to restrict it sometimes in a way that will make sense. In our case, time couldn't be negative, height couldn't be negative.